The second part of today's tutorial is related to the algorithm evaluation. So again, you have much more details in the lecture, but what is generally what we understand as evaluation on this tutorial. So often when we develop the model, the predictive model that should predict something, and predictive models, they are the part of prediction data mining. So we don't now talk about the descriptive data mining. And in prediction, we have regression and classification as a tasks. When we evaluate this model, what we actually want to do, we want to check how accurately this model predicts a novel, previously unseen observations. So in simple words, all right, we, for example, for the classification tree, we develop the tree, we know which questions are the best to ask, and then we take some other model, some new information about the customers that this model has never seen, so that this model never used in the training process, and we want to see, all right, how well our model can predict that information for the new customers. And it looks something like an exam. We know the correct answer, so we know which customers left our company, no or not, but model has never seen this data, and we want to see how good predictions of this model will be. Here about approaches to simulate real-life application, it is discussed in the lecture, but we will now talk about indicators, which we can really calculate. So indicators, these are measures that we can use to really evaluate how well our model works. And these measures, there are many of them, and they are slightly different for regression and for classification. Why are they different? Because in regression we have continuous dependent variable. In classification we have categorical or binary variables. And on the next slide, yes, here we have, so this is the list of these measures, and here are their formulas. So we will start now from regression, and we will make an exercise for regression. So in regression, basically, we want to predict a continuous variable. Here we see we want to predict sales, which is continuous. It can be 10,500 or 10,000 or 11,000. We want to make this prediction based on the price. And then, of course, as what you found in the lecture, we build our model as the line, linear regression, therefore, yes. And when we build the line, now we take this novel, never seen by the model data. On this visual representation, we can graph this data. So every of the squares, it's some data which this model wasn't trained with, but this is the data that is historical, and we know that this data is correct. So we know that for such price, historically, we had this sales. For such price, we had, we have this sales. And we want to see, okay, how far are these dots, data points from our line? Because if we wouldn't know the correct answers, and if someone would ask us what will be the sales if we have this price, we would look at our line and say, all right, our sales should be like this. But in reality, from the historical data, we see that they are a bit different. So we want somehow to evaluate how far what this line suggests is from a real data. And for that, we use these measures and these formulas. So what they basically mean, these formulas. Let's look at MSE. Almost always when you see E in this formulas, it means error. what is error? Error is basically the distance from our line to the point. How this distance mathematically is calculated? This distance is calculated. So now I talk about this E, this E, this E, and so on. It's calculated as the difference from the factual value and our prediction. And this is basically what is yi minus y hat I, where yi is the real value. For example, here on sales, if we look at this data point, it would be something like, let's say 10, I don't know. And yi hat, it's what our model predicts. And it would be, if it's 10, let's say it's 20. And when we calculate this difference, this is basically the error. That's what this E means. Then often when you see here S, it means squared. So it's to the power error to the power of 2. And if you look at this formula, it's really error and then to the power of 2. And then when you see M, it means mean. So all these three letters, they have a meaning of mean, square, error. And it's really like we first calculate how big is error for every observation. So we have here 1, 2, 3, 4, 5, 6, 7, 7 records, and for each of them we would calculate the difference between what our model predicts us and what is reality is. We would calculate the error, and we will look at it now in the exercise. Then we would find the square of every error, and then we would find the average of this squared error. The same when we calculate ME, it's mean absolute error. And you see that these formulas are exactly the same, except that here we don't find the squared, we find the absolute value. Then ME, it's, if you come back to the, again, to this list, on the previous slide, it's mean average percentage error. And we calculate it as the, we divide just this error by the real value. And when we calculate it, we know that this is the, what is the percentage of error from the real value. And again, we find the absolute and average. And then if you look what is RMSE, again, this is root mean square error. So from the name, you understand that we need to find this mean squared error, and we have for this formula, and then we find the root of it. Actually, why do we need this root mean squared error? Because when we find the average of squared error, it's quite difficult to interpret it. So if our error is always, let's say, 10, then we can somehow, or if our mean absolute error is 10, we can somehow interpret it, like if it peak or not. But if we know a square of that error, we cannot interpret it. And when we find the root of this squared error, we can bring it back from power 2 to, so to say, power 1, and somehow get the measures that easier to interpret. About the classification, we will talk before we start the exercise, but now we are asked to calculate these measures, assess the model, and we are provided with the predicted and real values of the regression. Let's open the, so this is algorithm evaluation draft. That's the file that we have. Here, like this, you already have here some formulas, and you have on the tab regression. For the regression, two columns. One is y. Y is the real value. If I go back to the slide, if we talk about sales, it would be sales for this point, sales for this point, for this point. Every row is represented in some of these points. And y predicted, it's what our line, what this line tell us the outcome should be. And now we want to calculate all of these measures. So we always, before we calculate any measures, we need to calculate, of course, the error, because this is the basis. You see this E is everywhere. So let's calculate error. As I said, error, it is the difference between equal to, I think I will change the dimensions of the screen so it's bigger. So it is the difference between factual value, which is column y, minus and predicted value, which is y predicted in this example. Okay, and I calculated for every record, so I can just choose here override of. So I copy this formula everywhere below. This is the error. And this is the basis of our calculations. But now, to calculate mean squared error, we first need to calculate the square of this error. We have an error, now let's calculate its square. So, error squared to the power of 2. Of course, it's equal error column to the power of 2. And again, I can copy this formula. Well, now when we calculated the squared for every error, of course, we can calculate their mean or average. I could use formula for that, so I can, even if I select now all these squared errors, I already see here the average in Excel. But then I could also use the function in Excel to calculate average, but I will do all my calculations like close to the numbers, to these formulas. So first I need to know n, right? N is equal to, I can use count, how many records I have in this table. And we have 100 records. And therefore, mean square error will be calculated as sum, you see sum, of all squared errors. Let's use simply sum of all squared records. So of this column, error squared, divided by the n. And it's equal to 827. As I said, it's mean of squared error. It's difficult to say what exactly that means because it's like square of error, difficult to interpret. That's why we will calculate the root of mean squared error, and it's equal to, so square root of mean squared error, and it's 2876. And then if you would know about which measures we talk here, it would be much easier to interpret it, because then we know that our error is something like 20, if we talk about euros, 28 euros, if it's income per month or something. Now, next measure that we want to calculate is mean absolute error. Basic element of it is absolute error. So now we will calculate absolute error. So here will be error absolute, and it's equal to, so you know the absolute value, it's number with positive sign. Therefore, I can use here simply function apps in Excel, and then reference error in this function. So I find absolute value of the error. Again, choose copy everywhere below, and again in the same way I want to find the average of this absolute error, so not of squared error but of absolute error, and it will be basically almost the same formula. I will even copy this formula, put here. So mean square error formula I would copy to mean absolute error formula, and then here as a reference to the column we don't need error squared, we need error apps, and it's 2502. These two measures, they are always quite similar, but in statistics, due to several reasons, this root of mean squared error is preferred. We'll not discuss why, but this is calculated. If we talk about error euros, this will be euros, 29 euro, and this will be 25 euro. And MSE, it will be squared euro, which euro in the power of 2, which is difficult to interpret. And now we see that this is mean absolute percentage error, and for that we need to calculate, of course, another column, which is now we will call error percent. Error. And this error percent we calculated, it's written here. It is calculated as error, so we can just reference error, divided by real factual value. So by this. Let's see what we get. So yes, and basically since it's percent, we want to represent it as percent. So let's do like this. So it's 229%. And what does it mean if we look at error? Where is my mouse? Okay. So if we look at the error, it's 17. Factual value is 8. It means that our error is double, or like even more than double of the size of real value. So even without knowing absolute like values in which we calculate this, in which we measure these items here, whether it's euro, millions of euro, and so on, we see here quite easily that this error is quite huge. Now I will calculate it for all the records that we have, and again we calculate the average of that. So I can simply again copy formula, and here instead of apps we use percentage. Okay. And that's how we basically calculate these 3 or 4 measures for the regression when we know factual and predicted values. And now we go back to the classification models. In the classification models, we don't have, as we had here, some continuous values. Our values in classification models, they are like categorical, or they are Boolean, true or false, or whether the item is really in that category, right? So we don't talk here about continuous variables, and therefore we most often as a measures we use something like here percentage of correct classified examples. and we calculate it as the number of all examples in this new never unseen data set for which we make prediction, which were correct, to all examples. So which, basically here we look which part of examples were classified correct. And then classification error, it's the it's the percentage of all records that were classified not correct. So we can here calculate it as the percentage of all wrong classification divided by all examples, or if we know PCC, we can just find it as 1 minus percentage of all correct examples. Here are more of these measures. So first of all, we need to look at the confusion matrix. And here we see, so we can see here the kind of errors and correct predictions that we can do. Let's reference, here is the example for some good or bad risk. Let's just say, okay, that good risk, here, good risk, it corresponds to value yes. So this is value yes. Bad risk to value no. Again, here, yes. Bad risk, no. Or it can be true or false, or 1 and 0, and so on. So let's say that we have some record, and we know that actually, in real, you see here, these columns are related to actual. It has the value yes. Then we look at the prediction. If our prediction also predicted that this record has value yes, it will be the case of true positive. So we found the true value, and this value is yes, it's positive. Then if our prediction would be no, it would be false prediction, and it will be false negative, because we made a negative prediction and it is wrong. The same as if we have actual value is no. If we predict that it's yes, we made a false prediction and it's positive, because we predicted it as positive, as yes. And if we would correctly predict it, it would be true negative, so it's correct and it's negative n. And therefore, we have here 4 measures. First, it's a percentage of correctly classified cases. Another formula you can see here, but what is, according to this system, what is number of all correct predictions? These are true positive predictions, where something is yes and we predicted it as yes, and plus true negative predictions, which is when something is not, and we predict it as not. So we find it as a sum TP plus TN, and we divide by all the predictions that we have. And that we have, it's basically all the cardinality, the number of elements in all of these 4 categories, because there can be no any other kind of false or correct predictions. Then error rate, again, you have formula classification error. So you can, if you know this PCC, you can calculate, and we can calculate error rate as 1 minus PCC. But also we can use this formula, which is basically all the wrong predictions. So these are false positive and false negative divided to the number of all predictions. Then we have the measure of specificity, and it says it calculates the total number of correct predictions for no, so true, negative. These are what we really correctly predicted for no values, divided by the total number of no values. And sensitivity the same, but for positive value, so total number of correct predictions for yes divided by the total number of records that have yes value. And in the exercise, we're asked to calculate all these four things here for the classification model. So we are given here factual value, which is 1 or 0, or you could interpret it as true or false, or you can interpret it as yes or no. Here it's true or false. Also, it's called good risk, bad risk for the some risk example. And this is the predicted value. And we want first to calculate all of this TP, TN, FP, FN, which are these subgroups. And then when we know them, of course, we can just apply this formula to calculate all the measures. So let's start the and we will first look at the true positive values. I will now add here the column. I will call it true positive, and this column, it will have one of two values, true or false. If it's true, it means that this record is true positive. It's false if it means that this record is not true positive. You can use some other ways how to calculate it. You can do it manually, but I will do this approach, use this approach. So, for example, let's look at the first record. We see that this is positive value. Y is 1, so it's yes or positive value, and it was correctly predicted. So it's true because it's predicted correctly, and it's positive because its value is 1. Its real value is 1. Therefore, I would write here equals or true. And I can do it manually. For example, here it would be false. Why it's false here? Because is it true? Yes, it's correct prediction, so it's true. But is it positive? No, because it's here we see that it is real value is 0. So it would be this record is related to the category true negative. Let's see here. Here would it be true positive? First of all, it's not true because we see that factual and predicted values are not the same. So it would be false. Oh, it would be false for this column true positive. But which case it would be basically? It would be false, and then it would be false negative because the real, no, it would be false positive because the real value is 0, and we predicted it as positive, so it's false positive. Okay, but I will use for that the formula to make this calculation automatic. So it will be and mean that 2 or more conditions should be correct. So all the conditions in the bracket should be correct and then it will return true. So here I want to write what are the conditions so that some case is true positive. Conditions are that real value should be equal to 1 and predicted value should also be equal to 1. If sum of these two is not 1, it will be definitely not true positive. It will be something else. And I can copy it below. Next, when we have true positive, let's calculate true negative. And true negative, to be true negative in the same way, it should fulfill two requirements that real value should be 0 and predicted value should be 0. You see we get here false because it's not true negative, it's true positive. And here we have true because because it's correct, and this is correct positive value. Now we go. Now we want to predict false positive. So false positive. What should be what are the requirements of false positive? I will write here formula start end. So to false positive means that the real value is no, is 0, but we predicted it as yes, as 1. So it means that a real value should be 0, predicted value should be 1. And we see that here we get correct because it was true positive. And let's find some true. So this is false positive because it's the real value, we predicted it wrongly, and it has positive, we predicted it as positive. And now last is false negative. And false negative, we calculated. So these are the values that false negative that have positive real value, but which were predicted wrongly to be null. And we see this is false negative because we predicted as negative and it was false. Now we did it for all the records. Now we want to count them. And to count them, I will use, so I can use it manually, just filter it by true, false, and so on. But I can use here count if function. So I will say that count if count values true positive in the column true positive if their value is true. I will have 46 cases in this column which have value true. Now I will do the same for true negative. I can copy formula there, but here I just need to change the column from TP to TN, true negative. Then FP, again, I can copy it and it will be FP, and the last will be Fn. So now we know all these cardinalities or number of elements in each of this group, and now we need to calculate PCC. PCC, it's equal to it's the proportion of correct predictions to all the predictions. So it's sum of correct predictions, these are true positive, true negative, divided by the total number of all predictions. So it's this. It's the sum of TP, TN, FP, if N. Error rate is the same thing, but we divide the sum of all total number of false predictions by the total number of observations. Then specificity, it's total number of correct negative predictions divided by the real number of negative predictions. So total number Tn divided by the sum of Tn plus Fp. So, and then sensitivity, it's again true positive, so correct positive predictions. divided by the number of true positive and false negative. So divided by the real number, correct number of positive. And then you can see that for ER, we can use this formula. So it's this formula, but also we could calculate ER as 1 minus PCC, and we would get exactly the same value. Because all values that are not correct, they are wrong. And this was it about model assessment. We looked at the regression model and now at the classification model. And that's it also for today's tutorial. So thank you for attention and have a good day.